everyone, in this video we'll learn boolean algebra. Boolean algebra is a small chapter included in the syllabus of the class 11 along with numerical numerical calculations. Now we have already studied the number systems. Numerical calculations mean number system. We have already studied the number systems. From today onward we'll study boolean algebra. Now, what is the boolean algebra? Before going to the boolean algebra, first of all we need to understand algebra. What does algebra means? Algebra is simply a branch of mathematics. That means mathematics is a broad term. It could contain the various terms, for example, calculus, trigonometry, geometry, and algebra too, and so on. And algebra is one of the small part of the mathematics that deals the algebraic structure and the manipulations using this algebraic structure. Now let's write the definitions of it. Algebra: the branch of mathematics that deals with algebraic structure and the manipulations using this. Yes, previously, as given in the definitions, this is simply a small branch of mathematics. Algebra is the small branch of mathematics that deals with the algebraic structure. The relations between the variable. Structure means algebraic structure or mathematical structure means the relations between the variable. Variables means variable could contain the value. Now, and the manipulation using this structure. Now let's take an example. What does this means? For example, this is a graph, x-axis, y-axis. Let's draw a straight line. Suppose this straight line make an angle theta with the x-axis. That means m represent the slope of this line, that is tan theta, and y-intercept is, let's say, c. Now slope of this line, we got m at the slope of the line and c the y-intercept. That means we can write the equations of this line as y is equal to mx plus c, where x is the independent variable, y the dependent variable. If we know the value of the x, we can determine the value of x. Now we can draw this line using this mathematical structure. This is called the algebraic structure or simply a mathematical structure. That means this is the algebra. We deal these types of equations in algebra. And not only this, but also manipulations using this structure is also belong to the algebra. For example, let m is equal to 5 for these equations and c is equal to 10. Now these are the constant. M and c are the constant for one particular line, and x and y change depending on the which coordinations we should take. Now let's value of x is equal to 2. For x is equal to, what would be the value of y? We can easily determine 5 into 2, 10 plus 10, 20. Now in this way we can calculate. For value of the x as 2, 3, we can also determine the value of y, and this all belong to the algebra. Algebra, the branch of the mathematics. Here we deal the algebra. Then what does boolean algebra means? Now look at here. In this algebra, here a variable can contain, that is the variable. These are the m and c are the constant. That means it have a fixed value. M and c have the fixed value. so that it is called the constant. X and y values depend varies according to the value. Thus, x and y could contain the any value for a single line. That means these are the variable. Now, algebra could contain the any value for a for this variable. Now, look at here. What does then Boolean algebra means? Boolean algebra is similar to the algebra. What the the variable contain only 0 and 1. The permitted value for variable are only 0 and 1. And the operations. This is the additions operations in this equations mathematical structure. Now the allowed operators in the Boolean algebra are only logical operator. Logical operator means and or not and so on. We will study later in this chapter. Now let's try the definitions of Boolean algebra. Boolean algebra. Boolean algebra is similar to the algebra but difference from ordinary algebra is 1. Values for permitted values for values are 0 and 1 only. Permitted operator are logical operator. Now, what is the difference between the Boolean algebra and algebra? Boolean algebra is a subset of algebra. Boolean algebra is nothing. It is also one of the branch of the algebra. But value permitted in the Boolean algebra are 0 and 1 only, and the operations between these values are logical operator. Logical operator. Now we understood the value 0 and 1. Variable should contain the value 0 and 1. Now what does logical operator means? Let's understand. Basic logical operator, or simply we can say a logical operator. A basic logical operator are those operator which is used to make calculate which a complex operator, or that means basic logical operators can satisfy the requirement of all the operator. Okay, what are these basic logical operator? One, conjunction operator, conjunction operator, or and operator, dot operator, mean operator. Now this in this way, conjunction operator can also say and operator, dot operator, or not operator. Now what is the second operator? Second is disjunction operator. This is also called or operator, also represented by plus, also represented by max operator, also called a max operator. Now, and another operator is not operator, also represented by this symbol. Now these are the basic operator, logical operators. Now conjunction operator and operator. What does the conjunction operator or and operator do? What does the conjunction operator performs? Now look at here. Conjunction operator. Conjunction operator is also called and operator for variable a and b. Let's take two variable a and b and AND operator. AND operator or operator we will understand from there. Now, how many combinations of input can be made from the two binary digit? We can make four combinations. How? 2 to the power 2, two variables. That means 2 to the power 4. What are these? 0, 0, 0, 1, 1, 0, 1, 1. And AND operator. AND operator gives the result. And for two input binary digit, AND operator produce only output 1 only if both the input are 1. This is also called 1 is also called high, 0 is also called the low. That means AND operator gives 1 high output only if its both inputs are high 1. That means in other case, if AND operator encounter any one input 0, that means 0, 0, 0, it produce 0 output. Now OR operator, disjunction operator. What does disjunction operator do? What does disjunction operator do? Disjunction operator gives output 1 if it encounter any one input having 1. That means, or in another word we can say, OR operator gives output 0 only if both of its inputs are 0. That means 0, 0, two input are 0. Now, so that it will produce 0. OR operator, it have one input here, at least one input, thus it gives 1. It will have at least one input 1, so that it produce 1. Both input are 1, that means it produce 1. Now, an AND operator, A dot V. How to represent? A and B are the input here. A dot V. And how to represent OR operator? A plus B. We have already mentioned it here. Now, plus means OR disjunctions. Now, what does the NOT operator perform? Now, AND gate and OR operations can take any number of input. Now, this is the 2 input AND operation. It can have 3 input also. What? And NOT operator. NOT operator take only one input and produce only one output. That means NOT. Suppose NOT of A. How to write? In this way we can write NOT of A. NOT operations takes only one digit and reverse it. Reverse means if input is 0, then it will produce output 1. If input is 1, then it produce output 0. That means A, negative of A have value 0, then it produce 1. A have value 0, it produce 1. A have value 1, it produce 0. A have value 1, it produce 0. In this way, this is called the logical operator. That means, what is the Boolean algebra? Boolean algebra use this operator and use binary digit. Now let's understand AND operator. 1 dot 1 dot 1 dot 1. What would be its output? This is the logical operator. What would be its output? Its output would be 1. Why? Because these are the AND operator, and AND operator produce output 1 only if all of its input are 1. Now, if any of the input have 0, now 1 dot 1 dot 0 dot 1. In that case, this produce output 0 because one of the input is 0. So so that we wrote output 0. Now it could be 2 0 also. If AND operator see one of the inputs 0, then it produce 0. To produce one output for the AND operator, all of the inputs should be 1. Now in this way. Now what does this mean in logical operator? In ordinary binary additions, this will produce 1 plus 1, 1 0, 1 1, 1 0 0, 1 0 0 0. This should product 1 0 0 for ordinary binary additions. But this is the OR operator, disjunction operator here. Disjunction. Now for the OR operator, this represents the OR operator. OR operator produce output 0 only if all of the input are 0, otherwise it produces 1. Or in another word, we can also say if any input have 1, if we in the series of the input, in the group of the input, if we see any input having 1, then output would be automatically 1 for the OR operator. Now what would be its output if we write 0? Still its output becomes 1 because 3 input have input 0. Now in that case, if all of the input are 0, then only at that case its output will be 0. Otherwise, if any input have 1, then automatically the OR operator produce 1. Now what would be the output of this? This is the negative operator, not operator. That means not of 1 would be 0. And again not of 0 would be 1. Now in this way the logical operator performs. Now AB plus BC, this is the, we can say this is the boolean algebra, where possible value of the A, B and C could be 0 and 1 only, and this plus means OR operations, and here nothing is present between B and C. That means we need to understand it contains the dot operator. Dot means AND operator, and this expression contains 3 variable, 1, 2 and 3 variable, and 3 operator also, plus operator, 1 operator. By default this produce the multiple, means AND operator, and OR, 3 operator. This is called the boolean algebra. Now we have already learned AND, OR and NOT operations. Now we'll learn GET. G-A-T-E, GET. What is GET? The logical circuit that perform logical operations. The device, we can also say device. The devices that perform the logical operations, it's called the GET. The circuit perform logical operations. The circuit or device that perform the logical operations is called the logical gate. How many gates are available in the real scenario? We cannot say how many gates are available, how many logical circuits are available, but we can say there are 3 basic gates to implement the 3 basic logical operations. There are 3 basic gates that perform the 3 basic logical operations. What are the basic logic operations? AND, OR and NOT operations. And to implement this three basic of logical operations, we have three basic gates. Now, AND gate, AND gate. The gate that perform the AND operations. The gate and the gate that perform the AND logical operations is called AND gate. What is the AND logical operations? AND logical operations. AND logical operations takes any number of input and produce 1 only if all of the input are 1, otherwise produce 0. This is the AND logical operations. Now, its diagram, circuit diagram. What will be the circuit diagram? We will draw in this way. Y, suppose Y is output. Suppose A, B. These two lines are the input, two input line, and this side represent the output line, one output line. Now this is called the two input AND gate because it have two input. If we add another line, then it is called the three input AND gate. Now in that case, Y equal to A dot B or A and B, we can write in this way. This is the logical diagram. This is the diagram of the AND gate, and this AND gate perform the AND operations. And what will be the truth table for these operations? We have already mentioned earlier. Now let's write again. AB. What are the possible values for AB? 0, 0, 0, 1, 1, 0, 1, 1. And Y equal to A dot B. What would be? This will produce 1 only if all of its input are 1. That means both input. If both input are 1, then it will produce 1. Otherwise, it will produce 0. Now, here in diagram, if we put value of A 1, value of B 1, then what would be the value of Y? It will be 1. In this way, this AND gate perform. Now, OR gate. OR gate. What is the OR gate? The gate that perform the OR logical operation. OR logical operations is called the OR gate. Now, what would be the symbol for diagram for OR gate? We write in this way. Now, this is also the two input OR gate, and OR is written by plus. OR operation is represented by plus sign. That means plus. And what would be the output of the OR gate? The output of the OR gate would be 1, 0 would be 0 only if all of its input are 0, otherwise it produces 1. Now, A and B both contain the 0, so that its output becomes 0. In another case, either A or B or both A or B contain 1, so that its output becomes 1. Now, in this way, OR operator performs. What would be G output if A is equal 0, B is equal 0, then Y will produce 0. OR gate. Then what is the NOT gate? NOT gate. The gate that perform not logical operation. Not logical operations is called the NOT gate. And what is the symbol of NOT gate? The symbol of, we need to draw a triangle in this way and need to append a circle, and we need to write in this part represent the input and this represent the output. This is the X, this is the Y. Now X, Y. What are the possible value of x? 0, 0 and 1. Not get takes only one input and produce only one output. But and OR gate can have any number of input, and based on the input we name it as 2 input OR gate, 3 input OR gate, and so on. Now possible value of the x are 0 and 1. Then what would be the value of y? 0. If input is 0, it produces 1. If input is 1, then it produces output 0. In this way, NOT operation work. What would be the value of y? If x is equal to 1, if x is equal to 1, y will become 0. Now this is called the NOT gate. And OR and NOT gate are the basic gates, because these gates can make any other gates, or these gates can be used to make all of the logical circuit. Now A B plus B C plus B A. A B plus B C plus C A. Let's see C A. A equal to 1, B equal to 0, C equal to 1. Now this is the boolean algebra, boolean expressions, and A is equal to 1, B is equal to 0, C is equal to 1. Then what would be the values of this? Now values of A is 1. 1, if there is nothing, we can write dot. B 0 plus B 0 dot 1 plus C 1 dot 1. And 1 dot 0 means AND operation. In AND operations, if one of the input is 0, then it produces 0 plus. It also contains the 1 0, so that automatically its output becomes 0 for AND operations. Now plus. Both input are 1 for AND gate, thus it produces 1. Now 0 or 1. What would be its output? Now the output of the OR gate becomes 0 only if all of the input are 0, otherwise it produces 1. Now let's take 0 or 0 produce 0 plus 1. 0 and 1 or produce 1. Now this 1 would be the 1 is the value of these expressions for this, for A is equal to 1, B is equal to 0, and C is equal to 1. In this way we can perform the logical operations. Now let's learn the De Morgan's rule. De Morgan's law. What is the De Morgan's law? Let me describe De Morgan's law. There is a two rule of De Morgan's. Now first rule, convert dot operator to plus operator. That means AND operator to OR operator. That means the complement of product of all terms. The complement means negative operator here. Here we can, negative operator is also called complement. The complement of product of all term is equal to the sum of complement of each term. Now let's say suppose A, B. Suppose A and B are two terms given. Now complement of produce of all terms are A and B. The complement of product of these two terms, where product means AND operator, is equal to the sum of complement of each term. What are the each terms here in this expression? A and B. The sum of complement of each term. Now This is the De Morgan's rule. First rule. 1. The complement of product of each term is equal to the sum of complement of each terms. Now, if there are three terms, A, B, C, what would be the expressions? Complement of product of each term equal to sum of complement of each terms. Now, we can convert this AND gate to the OR gate. Now, using the NOT gate. By using the NOT gate, we can convert AND gate to the OR gate. This is the De Morgan's first rule. And what is the second rule? The complement of sum of each term is equal to the product of complement of each term. Now, let me to repeat again. The complement of sum of each term is equal to the product of complement of each terms. Suppose A, B, C are three terms here. Then complement of sum of all terms and complement equal to product of complement of each term. Now, we have converted here plus to dot forms. Now, this is the, what is this? This is the De Morgan's rule. Second rule. De Morgan's have two rules. One to convert plus to dot, and another is to convert dot to plus. Now, we'll use De Morgan's rule to verify the universal gate. Okay, we'll learn before going to the universal gate. Before going to the universal gate, let's me to describe the truth table. Okay, truth table. What is the truth table? Truth table contain all the possible values of the variable and the combination of the variable. Suppose A and B are two variables, then the truth table contain all the possible values of this A and B and the expressions that contain AB. For example, suppose AB plus AB dash. Suppose we need to evaluate this. Truth table would be AB. What would be the possible value of A and combination of AB? 1, 1. Now, AB, we need to write each terms. First of all, B complement is given, so that let me to write B complement. B complement. What is the complement means? Negative. We can rewrite complement of negative of B as a complement of B, or this also represent the negative, not operator. And complement of B, 0 change to 1, 1 change to 0, 0 change to 1, 1 change to 0. Now, AB, A dot B, 0 dot 0, 0 0 dot 1, 0, 1 dot 0, 0, 1 dot 1, 1. AB complement. Now, product between and operation between this and this column, these two columns. 0 1 0, 0 0 0, 1 1 1, 1 0 0. Now, AB plus AB dash. Now, or operation between these two. 0 or 0 produce 0, 0 0 produce 0, 0 or 1 produce 1, 1 or 0 produce 1. In this way, we have evaluated the value of these terms for all possible combinations, possible value of combinations of A and B. Now, in this way, we can use truth table to calculate the value of expressions. Now, what is the use of the truth table? Truth table can be used to evaluate the value of the expressions or to demonstrate certain law. For example, To demonstrate the law, we can also use the truth table. Now let's verify the De Morgan's law using truth table. Let's take two terminology in the A and B. What is the De Morgan's first rule? A dot B complement is equal to A complement plus B complement. Let's verify this using truth table. A, B. What are the possible values for A and B? 0, 0, 0, 1, 1, 0, 1, 1. Now, AB. What are the possible terminology? We need to write all of the terminology expressed in the expressions. Now, A complement is also given, B complement is also given, AB is also given, complement of AB is also given. Now, A complement 0 change into 1, 0 change into 1, 1 change into 0, 1 change into 0. For B complement also 0 change into 0 change into 1, 1 change into 0, 0 change into 1, 1 change into 0. A, B. Now end operations between these two. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. Complement of AB. Complement of AB. This is the AB and complement of AB. 0 change to 1, 0 change to 1, 0 change to 1, and this change to 0. Now here also one terminology is given, A complement plus B complement. Now plus operation or operation between these two expressions. That means 1 or 1 gives 1, 1 or 0 gives 1, 0 or 1 gives 1, 0, 0 gives 0. Now let's see how this expressions is verified. How this expressions is verified using this table. Now we need to show A dot B complement is equal to A complement plus B complement. Now let's see. This AB complement is left hand side term and A complement dot B complement is right hand side term. Now for all possible value of the A and B, possible input for A and B, these two terms have equal value. Now 1 1 1 1 1 1 0 0. Now same thing happened for the three terms, three variable also. For 4 variable also, we can also draw the table for the 3 variables. That means we have verified the De Morgan's this law using truth table. Similarly, another rule also we can verify using the truth table. Let's see. What is the other rules? A plus B complement is equal to A complement dot B complement. Now AB, the possible values are 0 0 0 1 1 0 1 1. And A complement means we just need to change 0 to 1 1 to 0 for A complement. Now 0 to 1 0 to 1 1 to 0 1 to 0. For B complement 0 to 1 1 to 0 we need to change 1 to 0 0 to 1 1 to 0 this way. Now which terminology I have given we need to write down here. A plus B, A plus B, A plus B. Plus means here not ordinary addition operation, this means the OR operations. OR operations produce 0 only if both input are 0, otherwise produce 1. All input are 0, thus it produces output 0. The other input combinations contain at least 1 1, so that it contains 1. Now complement of this means negative of this, not operation on this. That means A plus B complement. This 0 change to 1, 1 change to 0, 1 and change to 0, 1 1 change to 0. Now again another terminology is also left, a complement dot b complement. A complement and operations between these two. 1 1 produce 1, 1 dot 0 produce 0, 0 dot 1 produce 0, 0 dot 0 produce 0. Now in this expression we get our left hand side terminology is a plus b complement, a plus b complement, and right hand side terminology is a complement dot b complement, a complement dot b complement. This is LHS, this is RHS. That means in all the possible values of a and b, we can see LHS is equal to RHS. LHS is equal to RHS. That means this expression is verified. We have verified the De Morgan's rule using the truth table. Similarly, we can find out the value of the any expressions where we can prove any valid expressions using the truth table. This is the use of the truth table. Now let's study universal get. What is the universal set? Universal get. Those get which are capable to make which we can use to make all of the basic gets is called the universal get. Universal gets are those gets which are capable to make all basic gets by themselves. This is called the universal get. Universal get. Universal get. Those get which we can use to make all the basic gets. Now what are these? NAND get, NOR get. NAND get and NOR get are called the universal get because NAND get can be used to make AND or NOT get. NOR get also can be used to make AND or NOT get. Now NAND get. Now this is the diagram of NAND gate. What would be its output? The output of NAND gate would be A dot B complement. NAND gate perform the AND operations and do NOT operations on the output of the AND operations. Now this is similar to the AND. This is similar to the AND gate except a small circle is appended on the end. Now these are the input. Two input NAND gate. This is called the two input NAND gate. What will be the truth table for the NAND gate? A, B for two input. What are the possible input are 0 0 0 1 1 0 and 1 1. And NAND gate. What will be the output of Y? Now let's first of all write A dot B. Dot means produce 0 0 0 1. And Y. What would be the output of the NAND gate? This should produce negative of this 1 1 1 0. This is called the NAND gate. And what is the NOR gate? NOR gate. To draw the diagram of the NOR gate, we just need to draw the OR gate and need to append a small circle at the end. This is called the two input NOR gate because it has two input. And what would be its output? Its output will be A plus B complement. NOR gate perform the OR operations and it invert the result. Now plus What would the a plus b? 0 1 1 1. And what would we do y? Y just invert a plus b in this case. Now 1 0 0 0. This would be the output of the NOR gate. Now let's see why NOR gate and NAND gate are called universal gate. We need to know that NAND gate and NOR gate are called the universal gate. NAND gate, why NAND gate are called universal gate? NAND gate are used to draw all of the basic gates, thus NAND gates are called universal gate. Now how? A NAND gate as inverter. Inverter means how NAND gate perform NOT operations. Let's draw a diagram circuit of the NAND gate. Why? Let's take two input NAND gate and connect both input to each other. That means only one input flow from both the input. Why we need to do this? Because inverter take only one input. Inverter means NOT gate. NOT gate takes only one input and produce only one output. A complement. How? A. Both A flow from here and A dot A. A dot A would be A for the AND operations. How? For 0. For A is equal 0, 0 dot 0 produce 0. For A is equal 1, 1 dot 1 produce 1. That means A dot A produce 1. 0 dot 0 produce 0 AND operation. 1 dot 1 produce 1. That means A dot A produce 1. And this NAND gate invert the output of the AND gate. And its output would be a complement. That means NAND gate work as an inverter if we connect two input with each other and we will send only one input. Now NAND gate as OR gate, NAND gate as AND gate. Let's say AND gate. What is the expressions of the NAND gate? A dot B. Now this is the expressions of the NAND gate. Sorry, this is the expressions AND gate. This is the expression of AND gate. We need to feed two input A and B to the NAND gate, and then that NAND gate should produce the circuit that is made from the NAND gate should produce A dot B. How to achieve this? We can obviously we can write to double complement here. Now look at here. Now how to draw this? Double complement. That means let's 0. If we give single complement, then it produces 1. If we again give a complement, it produces 0. That means if we give the double complement, if we do the double complement on a certain input, then it will produce the same input. Now for 1 also, if we give one complement, it produces 0, and if we give complement, then it will produce 1. 1 is inverted into 0, 0 is inverted into 1. That means input is similar to the output for double complement. That means to produce A dot B is similar to the A double complement. We can write A dot B as a double complement. That means one NAND gate, two NAND gate. Now how to draw this? Let's see. This is a NAND gate A, B. If we feed A dot B into this NAND gate, this will produce A dot B complement. This is the expressions of the NAND gate, and we have complement up to this. Now we again need one inverter. That means we need to make one NAND gate as an inverter. How to make this? We have already studied. We just need to append two input, and this will produce A dot B double complement, because there is a single complement and this operations again do one complement, that means double complement. A dot B double complement. A dot B double complement means A dot B, that means 0 double complement means 0, 1 double complement means 1. Double complement to the any input produce the same input, same output. That means double complement of A dot B produce the A dot B. Now, what are the requirement of the AND gate? That the AND gate should produce A dot B for input A and B. Now, same operations we have done using the NAND gate. So that we can say NAND gate as a AND gate. In this way, we can say NAND gate as a AND gate. Now we have used NAND gate to make NOT gate, that means inverter, and AND gate also. Now we need to make NAND gate as a OR gate. We need to use NAND gate to draw the OR gate. What would be the output of the OR gate? 4 in 2 input A and B. 4 in 2 input A and B. The OR gate should produce A and B. Now NAND gate should perform take A and B and should produce A dot B. A plus B. Now we can also append two complement here, because 2 complement means gives the A plus B. This do not change the input. This gives the same output. Now, by using the De Morgan's rule, now let's apply De Morgan's rule. First complement here. The complement of sum of all terms is equal to the products of complement of each term. That means A complement dot B complement. A plus B complement can be rewritten as A complement dot B complement, plus it changes into the dot, and the whole complement goes to the single complement to the single variable. And this we have not done anything for this complement. Now this gives the result A plus B. Now we can write here also A plus B. For A plus B, we can write double complement, and we can rewrite it as this by applying the De Morgan's rule. Now let's draw a diagram. This is the negative. We have already studied how to use NAND gate as an inverter. That means A B. We fed A into here and it will produce A complement, and we fed B into here, it produces B complement. A complement and B complement terminology we have already achieved. Now we need to perform dot and complement means NAND operator, one NAND operator. Now this will produce AND operator product of these two terms, and NAND operator append this. That means we have achieved this expression. That means we have achieved A plus B. This is equal to the A plus B. Now for two input A and B, we have achieved A plus B. That means NAND gate as an OR operator. Now we have used NAND gate to draw all of the basic gates. Thus NAND gate is called the universal gate. NOR gate as a universal universal gate. NOR gate as a universal gate. To demonstrate the NOR gate as a universal gate, we need to use NOR gate to draw all of the basic gates. All of the basic gates means NOT gate, OR gate, AND gate. Now, NOR gate as a inverter. Inverter means NOT operations. How NOR gate act as an inverter, or how NOR gate perform NOT operations. Now, what is the diagram of NOR gate? This is the diagram of the NOR gate. Now, let's connect these two circuits. Let's give A, the both A and A flow here. Now, let's see. 0 plus 0 would be 0. 1 plus 1 would be 1. This is not the ordinary binary additions. This is the OR operations. If both input are 0 for OR operations, then it will produce 0. If any one of the input is 1, then it produces 1 for the OR operations. Plus means OR operations here. Now, similarly, A plus A equal to A. We can say A plus A equal to A. 0 plus 0 produce 0, 1 plus 1 produce 1. These are the only possible values. And so that we can say A plus A equal to A. That means A plus A produce A. And this circle represents the NOT operator. NOT operator produce complement of A. A complement. For input A, NOT operation produce A complement. That means if 0 is given, NOT operator produce 1. If 1 is given, then NOT operator produce 0. That means if 0, now in this way, if A is given, if A is the output of this OR operator, then negative of complement or NOT operations of A produce A complement. Now this is our required output for input A. To demonstrate NOR gate as an inverter, we have used inverter here. We have used NOR gate here. Now, our next step is to demonstrate NOR gate as a OR gate. NOR gate as a OR gate. We need to produce A plus B. We need to produce A plus B for input A and B. To demonstrate by using the NOR gate, we need to produce A plus B for input A and B by using NOR gate to demonstrate NOR gate as a OR gate. Now, for this is equal to the A plus B double complement. Now, why? Because single complement of 0 is 1, and again if we do the complement of 1, it gives 0. That means input is given output. That means double complement of these terms is equal to these terms only. Now we use NOR gate to depict these expressions. Now let's see. This is the NOR gate. A, B. What will be its output? A plus B complement, because OR produce A plus B and this circle produce negative. This circle produce complement. That means A plus B complement. And again we need one complement. That means we can use NOR gate as an inverter. How to use NOR gate as an inverter? To use NOR gate as an inverter, let's connect to circuit, and this will produce A plus B double complement. This will perform NOT operations on it. That means a complement a line on these expressions. Now this is similar to the A plus B. Thus we have successfully demonstrated NOR gate as an OR gate. Now NOR gate as a AND gate. AND gate. How to demonstrate this? A dot B. For input A and B, we need to produce A dot B. To to demonstrate NOR gate as a AND gate using NOR gate. We need to use NOR gate to produce A dot B for input A and B to demonstrate NOR gate as a NAND gate. For this, now this can be rewritten as A dot B double complement. That means complement A complement plus B complement. If we apply De Morgan's rule here, then this will gives this result expressions, and this we have not done anything for this line complement, so that we have written as it is. Now we need to use NOR gate to draw this diagram. First of all, we need to find out the complement of A and B. Now we will use NOR gate as an inverter to find the complement of this A, B, B. Now we have found A, B. Now NAND expressions. A complement, this will give B complement, and summation of A complement plus B complement, and invert this. Now this will give A complement plus B complement and whole complement. This expression is similar to the A dot B. That means we have demonstrated NOR gate as a AND gate. From here we can say NOR gate and NAND gate as a universal gate, because NOR gate and NAND gate are individually able to draw all the basic gates. Now let's see another available gates. XOR gate. XOR gate perform the exclusive OR, also you can also say exclusive OR, and represented by this sign. And what would be its output? For two input. If input are same, then output would be 0. If input are different, output are 1. Now for the same input it produces 0, for the different input it produces 1. What would be these expressions? Now let's draw the diagram first. Its diagram would be like this. Same as the OR gate, and we need extra curve here left to this curve. Now for A and B, what would be the expressions of this output? A complement B plus A B complement. Output A complement B plus A B complement. Now let's draw truth table. A B. Zero 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 one one zero one one. For same input A XOR B. For same input produce 0. For different input it produce 1. Let's demonstrate how this produce this result. A complement B. A plus B. A plus inside the circle. 0 0 1 1. Now A complement B complement. A complement 0, A complement 0 to 1, 1, 0, 0, and B complement B 0, so that it will become 1, 1 to 0, 0 to 1, 1 to 0. Now A complement B. What would A complement be? A complement B into, that means 0, 1. Here 1, 0, 0, 0. A B complement. A B complement. A B complement. 0, 0, 0, 0, 0. 0, 0, 0, 0. A B complement. B complement. What is B complement? A B complement here. It gives 1. Now plus. Plus means or between these two equations 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 0. Now look at here. For the same input it produces 0. For the 1, 1 also it produces 0. For the different input it produces 1. That is the logical operations, logical output of OR gate. Now XNOR. XNOR gate. XNOR gate means exclusive NOR gate. This is represented by this sign. For two input, if inputs are same, then its output would be 1. If input are different, output would be 0. Now this is the reverse. Now its diagram would be 0. The negative of the inverter of XOR would be XNOR. The negative. If we make complement on this expression, then it would give XNOR. That means A XNOR B is equal to AB plus AB bar. Now in this way, AB bar or A dot B bar. Now in this way. And this way, this is the expression of the XNOR. Now we have completed almost all the things that is needed by this chapter. Now thank you everyone, keep watching the video.